Viewers and followers. Before us in this very question, if you remember in our last class, we calculated the length of an arc, right? So, and at times, the question might not come in the form of calculating the length of an arc. We might be given the length of an arc and asked to calculate the angle subtended at the center or the radius, depending on how the question is what set. Okay. In this very question now, we are actually given the length of the arc. We have that what angle does an arc 6.2 centimeter in length subtend at the center of a circle of radius 14 centimeter. You can see that for this question we are given the radius and we are given the what? The length of arc. And we are asked to find the angle subtended at the what? Center of the what? Circle. Okay. Now how do we go about it? Then let's do a sketch. If you like, you can sketch the question. Okay. If you like, you can go ahead and apply your formula and solve. But most of the time, I like to give you a sketch. That as a guide to my solving. Okay. So let's sketch our circle. This is the center. Okay. My radius here is 14 centimeter and this is 14 centimeter. The angle at the center is what we don't know. But we are told that the length of this arc from here to here, the length of the arc is given as what? 6.6 what? Centimeter. Okay, that means from here to this very place is 6.6 what? Centimeter. Okay. So we are now asked to find the value of this what? Angle here. So how do you go about that? First of all, we need to write the formula for length of an arc. Okay. Length of an arc L is equal to what? Theta all over 360 times what? 2 by 1 R. Okay. From our question, we are looking at our L is 6.6 centimeters. Okay. Our theta is given as what? We don't know. That's what we are looking for, right? Then our radius R is given as what? 14 centimeters. And we are told to take pi as 22 by what? 7. Okay. Now let's substitute all these parameters into this very word formula and look for the very value of this word pi that we are not given. Okay. So we have our word. Our L is what? 6.6 centimeter to be equal to what? Theta over 360 times 2 times 2 by 7 times. Our radius is 14 centimeter, right? Okay. So from here now, what are we to do? We are going to multiply out all the values we have at the what? Numerator, right? So I'm going to have 2 times 22, that is 44. 44 times 14, that will give us 616. So I'm going to have this as 6.6 centimeter equal to what? 616 theta. Multiplied by theta, I'm going to have this as centimeter all over 360 times 7. That gives us 2,520. So you can see that this is in fractional form. So we can make this to be the same form as this, okay? By this as by 1. Okay? From here, we have to make this theta the subject. So we can as well cross multiply. Having this subtract this and this multiply with this. So we have what? 1 times 616 theta in centimeter to be equal to what? This. Okay? 616 centimeter times 2520, right? So we haven't done that, but apply this out to give us 616 theta centimeter to be equal to what? 25 times 616. So I will be having 1663 what? 2. Now our aim is to make this theta to stand out. Okay, how do we make this theta to stand out? By dividing 2 by what? 616 what? Centimeter. Okay, so we can divide 2 by 616 centimeter. This over 616 centimeter. So centimeter cancels out and 616 cancels out 616. So we have our theta equal to what? This is also in centimeter. So centimeter cancels out. We are left with what? 16,732 divided by 616. Okay? So let's divide it by 616. So I will be having what? Our theta will equal to what? 27 degrees. Okay? As simple as that. You can see any of the parameters can be made as what? Unknown. Okay? Just as in this case now, the theta is made as what? the unknown is the formula. Okay, invariably our radius can be made as unknown. So the same way we substitute the values, we substitute the values like this, and the very one that is not given, you make that very one the subject of the formula by define and use it as your final answer as regard to what you just did here. So as simple as you can see, mathematics is not as difficult as most of you think or take it to be most of the time. Okay. So we would love to see in our next class. In our next class, we'll diving into how to calculate the perimeter of a given sector. So we'd love to see you again. Bye bye.